Hi everyone, today we're looking at lessons 9 and 10 in Module 1, and this is where we're really going to start getting into the idea of scientific notation. So Module 1, Lesson 9. Introduces us to scientific notation. Now scientific notation is really just that form that we've been using for a few days, where we have a whole number and we multiply it by 10 to a power. So what we're going to be able to do is write, add, and subtract numbers in scientific notation. And we want to understand what is meant by the term leading digit. Now, if you're leading, then most often you are in the front. So the leading digit is just that whole number that's out in front of the scientific notation. So looking at just kind of a quick example, the number of stars in the universe is approximately 6 times 10 to the 22nd power. So this is a 23-digit whole number because I have that 6 followed by 22 zeros. It has a leading digit that is equal to 6 because that's kind of my front coefficient. And then the other kind of term that we want to know is called the magnitude. And the exponent is known as n and is called the magnitude. So our magnitude is equal to 22. Basically tells us how many zeros would come after the leading digit. So just by examining that value in scientific notation, 6 times 10 to the 22nd power, I know how many digits there are, I know the leading digit, and I know the magnitude. So let's look at an example where we actually have to use this information. The difference in population between Texas and North Dakota. So in Texas, I have 26 million people, while in North Dakota, I have 69,000 people. And I'm going to write these values in scientific notation so that it's easier for me to subtract because it's asking me to find the difference. The difference is the solution when I subtract. So I would take the larger number and try to subtract the smaller number. So 2.6 times 10 to the 7th power minus 6.9 times 10 to the 4th power. Now the tricky thing about this form is that my tens are representing different powers. And really, I want them to have the same power. So I'm going to rewrite that 2.6 to be 2,600. It includes 3 more digits, which means now I can write it as 10 to the 4th and still get the same value. And then I keep that 6.9 and subtract. So I get 2,593.1 times 10 to the 4th power. Or an approximate solution of 25,931,000. Moving on to Module 1, Lesson 10. We're going to continue to look at operations with numbers in scientific notation. So that means we're going to add, subtract, multiply, do all those good things with values in scientific notation. So our objective says students practice operations with numbers expressed in scientific and in standard notation. So let's look at another example. If I'm given a world population of approximately 7 billion, And I know that there are 4.6 times 10 to the 7th power ants per human being. How many ants are there in the world? So this is a multiplication problem. I know how many people there are. I know how many ants per person. But in order to make it simpler, I want to write using X scientific notation. So 7 billion can be written as 7 times 10 to the 9th power times 4.6 times 10 to the 7th power. I'm just going to multiply those leading coefficients, 4.6 times 7, and I got 32.2, times 10 to the 16th power. And I just got that by adding 10 to the 9th plus 10 to the 7th. That's one of my laws of exponents. And then I can rewrite my solution to just have one leading digit, which gives me 3.22 times 10 to the 17th power. Another example says Facebook gets 990 billion likes per year. If there are 8.9 times 10 to the 8th power Facebook users, how many likes does each person get on average? So this is a division problem. 9.9 times 10 to the 11th power over 8.9 times 10 to the 8th power. If I simplify just my coefficients, 9.9 divided by 8.9, and my 10 powers separately, I get 1.1 times 10 to the 3rd, which is approximately 1,100 likes per person.